As we look at reactions of acids or bases or titration calculations, a couple things are super important to remember. First of all, we're looking for the equivalence point where the moles of acid is equivalent to, or a lot of times we can say equal to, but equivalence is a slightly better word because we are thinking about having enough hydrogen for our hydroxide, which does mean we need to account for our mole ratio. The second thing, whether we're strong or weak with weak or weak with strong, whatever combination of strong and weak we have, because these neutralization reactions are going to produce water and a salt, that water is producing water is a one-way reaction. After that, we may have some other questions with equilibrium, with salts, with all of that, but the making of the water or the acid-base reaction is one way to completion and therefore stoichiometry. So here I wrote out a generic equation showing the reaction of that acid and base. But you don't necessarily need to do that, but we do need to account for the mole ratio of our acid to base. So then we take the information that we know, the volume and the molarity, to get the moles of the base. We know from the 1-to-1 mole ratio that moles of base equals moles of acid. And in this case, rather than being asked for a concentration or molarity, like a lot of titrations do, we're trying to find out the molar mass. This is probably a solid, as it says, that we dissolved in some water. So we can take those grams per the moles that we have. Since it's grams per mole, if I know that I have 1 gram and I have this many moles, dividing that tells me my experimental grams per mole. And we've got that as 93. Sometimes we can then use that to figure out, well, what is the anion bonded to hydrogen? The other thing that's very common in titration calculations are error analysis. If we didn't rinse our burettes, if we didn't dry our solid, if we overshot our endpoint and our equivalence point, meaning added too much of something. So with those, it's not necessarily something you can just jump to the answer of. You'd want to think, is that going to increase or decrease the volume of base? Once I've done that, what does that do to the moles, to the moles, to the moles, then to the molar mass? If this is too large or too small, take it through that whole progression. If the mass of solid is too large or too small. If we haven't rinsed our glassware, then that means in general, that's going to drop our molarity. The dropping of the molarity won't really change this value because we assume it to be the same, but it's going to require us to use a larger volume of that because it's a little bit watered down. So thinking of the error analysis in terms of the calculations that you either did or would be doing is very important. Not just guessing, eliminating the ones that couldn't be an error that would make sense, but then kind of working through the math, what's bigger, what's smaller, and how does that change my final answer is what you're looking for.